this video, we're going to be taking a look at section 2.8, which is on distance and midpoint formulas and on circles. So let's go ahead and take a look at the first topic, which is how to find the distance between 2 points on the Cartesian coordinate system. So if you're trying to find the distance between point 1, which is located right here at x1, y1, and point 2, which is located here at x2, y2, you want to find the length of the line segment that connects those 2 points together. So that would be our distance. Now I can remember when I was, in school at some point and being faced with this problem, my first instinct was to find a ruler. I was like, well, if you want me to measure that distance, why can't I just find some meter stick or a ruler of some type and just put it on my paper, and then I can measure it that way from point to point. And that method actually could work if you were very careful about how you set up the graph. So if you marked your x and y axis so that each mark counted as exactly 1 inch, for example, and then you very carefully plotted your 2 points, then a ruler would actually give you the distance between those 2 points. But that's a lot of work to set up the graph so that it's done as accurately as it needs to be, and in order for that technique to work. But also, let's say the distance is like square root of 2. Well, that's going to be hard to read off of a ruler, right? It'd be some kind of decimal, it'd be in between 1 and 2. That wouldn't be very helpful either. So we want a more precise way of measuring that distance. So the difficulty here is that measuring the distance diagonally is challenging to do in algebra. But what is not so challenging is measuring the distance horizontally and vertically, right? So we can measure the distance horizontally between these 2 points, the horizontal change, which we've done for finding the slope. We've used that type of measurement before, and that's easily enough done. All you have to do is subtract the x-coordinates, and that'll tell you how much how much distance there is horizontally between the 2 points. And then we can measure the distance vertically between the 2 points, right? That'd be this line here. And that's easily enough done, just like we did for finding the slope. To find the vertical change, you just subtract the y-coordinates. And don't worry about the absolute value here. It's not going to matter in the end anyways. And then we could find the diagonal distance using the Pythagorean theorem, right? Because when you look at the horizontal and the vertical distance, and how it relates to that diagonal distance between the 2 points, the shape you get is a triangle shape, and it's specifically a right triangle. And for a right triangle, the sides are related by the Pythagorean theorem. So we have a squared plus b squared equals c squared. Except that instead of a, we have the change in the horizontal direction. So we're going to have x2 minus x1, and that's going to have to get squared. And this is why the absolute value doesn't matter, because when you square it, that's going to make it positive anyways, so we don't really need to keep the absolute value around. And instead of b, we have, so I guess maybe I could draw arrows here, we have the change in the vertical direction, which is y2 minus y1 squared, and we're going to add those two together. So we're adding, and then c squared is the distance, right? C is the distance we're looking for, which we're calling d in the situation that we're examining on the left-hand side, and that has to get squared. And so you end up with this formula here, which is called the distance formula for finding the distance between 2 points, but it is simply the Pythagorean theorem, but just, modified for the scenario that we're looking at, right? It's really just a squared plus b squared equals c squared. That is the distance formula. And so that's what we have on the chart here. Now, this formula looks a little different than what we have here. I honestly prefer leaving the formula in this form, but if you really want to solve it for the distance, you want to get rid of that power of 2, you would just take the square root of both sides, and that gets you to the formula that you see on the screen here. All right, so what we're going to look at are a couple of examples for finding the distance between 2 points. We're going to use this formula, and like I said, I really prefer using the formula without the square root there. I just think it looks more elegant, and it more closely connects back to the Pythagorean theorem. And the only extra step that's going to add to our work is that when we're finally done simplifying the right-hand side, we'll have to take the square root of both sides instead of having the square root already there. All right, let's take a look at an example. So we have a couple of examples here. So just like we were doing for the formula for slope, we're having to plug 2 points into this formula, and they're labeled in just the same way that we label points for finding slope. And so I would recommend, just to make sure the numbers get plugged in the right way, to label our points. So this is my first point. It's an x and a y, so I'll label that as x1, y1. This is my second point, so I'll label that x2, y2. And then I plug the numbers in the way I have them labeled. Right, so we're going to have the distance squared equals x2, which is 2, minus x1, which is 10, plus, and that has to get squared. I didn't say that out loud, sorry. So x1, which is 10, squared, plus y2, which is 8, minus y1, which is 2. That has to get squared. And then we just simplify the right-hand side. So this is going to give me negative 8 squared plus 6 squared, which will be 64 plus 36, which is going to be 100, right? Which is a really pretty nice number to have here. The last step will be to take the square root. So we'll take the square root of both sides. Now, usually in the past, when we've taken the square root of both sides of an equation, you're supposed to do plus or minus, but we don't have to do that here because the distance can't be negative. So because the negative answer doesn't really make sense for the situation we're dealing with, we're not going to do plus or minus this time. We're just going to get 10, right? Positive 10 is the only reasonable answer for the distance between these 2 points. Negative 10 is not reasonable in this case. All right, so that's using the distance formula. I'm sorry I didn't copy d squared down here, but that was there the whole time. That's the distance formula, and this was actually kind of your Cinderella situation here, right? This nice numbers to work with, you get a nice answer. That isn't always going to be the case, and so we see over here for part B, we have a much scarier looking situation, but we're going to address it in the same exact way. This is x1, y1. This is x2, y2. We'll plug now. I'm not going to rewrite the formula. I'm just going to plug the numbers in directly to the formula that I already have on the screen. So we're going to have b squared equals x2, which is 1/3, minus x1, which is 16/3. Now, while these are fractions, at least they gave us that mercy that the numbers we're going to be adding or subtracting, at least at this point, will have a common denominator already, so that's going to make things a lot easier. In fact, it looks like it just works out nice after that. So it looks scary at first, but once we get into it, we already have a common denominator, and we end up getting nice numbers, it looks like, at least for this one. I'm sorry. Now, I guess let's just go ahead and take a look at y. We have y2, which is 6/5, minus y1, which is 1/8, which again is going to work out beautifully. So this actually is not as bad as it looks. So slide over here a little bit. I'll have to square that. So again, we already have a common denominator, so we can go ahead and subtract. 1 minus 16 gives me negative 15. The common denominator there is 3. And so I don't leave you in suspense here. Let's just go ahead and simplify that. Why did I put a 3? 2, right? So negative 15 divided by 3 is just going to be negative 5. And then negative 5 squared is going to give me 25. So that works out pretty nicely after all. Here we're going to have 6 minus 1, which is going to give me 5, over the common denominator of 5. 5 divided by 5 is 1. 1 squared is going to give me 1. Right. So we end up with, I guess I'll write it over here, we end up with d squared equals 26. So we do want to take the square root, but you don't want to do that while you still have the 2 numbers here. You want to go ahead and add those 2 numbers together. Then you take the square root. And this one does not work out as nice, but that's, no sweat off our brow, right? It just doesn't work out nice. That's my answer then. I don't have to simplify it because you can't take the square root of 26. It doesn't simplify in any nice way. And I assume, again, on my math lab, that is the way they'll want you to type in the answer in radical form. Now that's not a very satisfying answer as far as like, well, what's the actual distance then, right? So if you really want to know like how far that is, then you might want to get the decimal version of that number, and it's going to be something like 5.1, something like that, right? So, but again, I wouldn't do that unless my math lab asks you to do that. So I just leave it in radical form unless otherwise directed. Okay. That's the distance formula. That's the first topic we wanted to talk about. The next topic is the midpoint formula, right? So the midpoint formula is the point that's exactly halfway in between two given points. So I don't see an illustration here, so if we just go back to the previous screen and look at this graph, not that it's marked on here, but we can kind of estimate where it would be. Let me pick a different color. The midpoint will be like right here, for example. So the midpoint is the point exactly halfway in between 2 points on the line segment that directly connects those 2 points, right? So it'd be something about right there. Now, to find the midpoint between 2 points, you want to know the halfway point for the x values, because that's where that midpoint's going to show up, halfway between, where it's going to show up on the x-axis is exactly halfway in between the two x coordinates of your 2 points. And it's going to show up exactly halfway in between the y coordinates vertically, right? So what we really want to figure out is what number is exactly halfway in between our x coordinates, and that'll tell me the x coordinate of the midpoint. And we want to find out the number that's exactly halfway in between our y coordinates, and that'll tell me the y coordinate of our midpoint. And if you have two numbers and you want to find the number that's exactly halfway in between, you just take an average. So that's all that's happening here. So let me try to draw that circle again. So to find the x coordinate of my midpoint, I average the x coordinates of the 2 points that I've been given. And the way you take an average with two numbers is you add the two numbers together and you divide by 2. So that literally is all you're doing here, is taking an average of the x values by adding them together and dividing by 2, and then taking the average of the y values, which is what's happening here. And that gives you the y value of your midpoint, the y coordinate of your midpoint. All right, so that's the formula. So again, you can memorize it, x1 plus x2 divided by 2, but you could also just remember it's just an average. So take the x coordinates you're given and average them out. Take the y coordinates you're given, average them out, and then you don't have to worry about like using a complicated looking formula. That being said, so the way I would think of it is just take the average, but I'm going to use the formula to demonstrate these problems for students that would prefer that method. So I'll write the formula down, right? So we have x, why am I putting a bar here? I guess that's the notation you could use for that, but I'll just say this instead. Midpoint equals, sorry, I did a bad job here. X, I'm really just messing this up. Let's just start over. Okay. If I wasn't so lazy, I would cut that out of the video, but I don't think I'm going to have time to edit, so I'm just going to leave it in there. The midpoint equals x1 plus x2 divided by 2. So let's do that. And then y1 plus y2 divided by 2. So again, label the points, x1, y1, x2, y2, plug them in the way they're labeled. So we have x1, which is 10, plus x2, which is 2. So notice one big difference with this formula that throws students off is that we are adding, not subtracting. So for the slope, you're subtracting the y coordinates and the x coordinates. For the distance formula, you're subtracting. But for the midpoint, you actually want to add the two numbers together and then divide by 2. y1, which is 2, plus y2, which is 8, divide that by 2. And that's our midpoint. We just need to simplify this, so we're going to get we'll have 12 over 2. And again, they're just being nice with these numbers here because it just works out so beautifully. We get 6, 5. So we get 12 over 2 and 10 over 2. So that's the point exactly halfway in between 10, 2 and 2, 8. All right, for part B, again, this one looks a little scarier, but I don't know. Hopefully we luck out like we did last time, and this kind of works out nicer than it looks like it's going to work out. So again, x1 and y1, x2, y2. I'm just going to go off the formula that I already have on the screen. So we'll have x1, which is 2, plus x2, which is -10, so be careful with that negative sign. I'll use parentheses around that, over 2. That's my x-coordinate. The y-coordinate will be y1, which is 3 square root of 6, plus y2, which is 7 square root of 6 over 2. And then we'll simplify. So we know, of course, plus a negative just means you're going to subtract there. So that's going to give me -8 over 2, right? 2 minus 10, -8. Here, because these have the same radical parts, they're like terms, so we can combine those together. 3 plus 7 gives me 10. The radical part stays the same. So we get square root of 6 there, over 2. And then we reduce these fractions, and so we will get -4 as our first, our x-coordinate. And then the 2 cancels out with the 10, leaves me with a 5, but the 2 cannot cancel out with a number inside the radical. So that number inside the radical is cut off. We can't interact with it from outside the radical. So it's just going to be 5 square root of 6. And that would be the midpoint for part B. All right, let's go ahead and take a look at the next topic. So the next topic is circles. Now, you might find this is a strange topic to be bringing up in this section, right? What does this have to do with distance and midpoint? But it actually has a lot to do with those two formulas. All right, so let's start with the definition of a circle. A circle is the set of all points in a plane that are equidistant from a fixed point called the center. So that's an important term there. The fixed distance from the circle's center to any point on the circle is called the radius, which is another important point. So if you take a point as your center and you grab all the points that are the same distance away from that center, the shape that's going to create is the shape of a circle, the shape that you learned in kindergarten as the shape of a circle. The center is labeled as h comma k, and then we have a bunch of points. So there's only one center, but we have an infinite number of points around the circle, right? There's an infinite number of points that are whatever distance away from the center. So we represent those points with just a generic x comma y with variables, right? Because there's infinitely many points here. The values can vary. My voice just cracked, which is kind of embarrassing, but I'm not going to edit it out. There's infinitely many points here, so the x values and the y values can vary, so we use variables to represent the points on the circle, and we use r to represent the radius. Now notice that we are talking about distance here, so it's kind of embedded in that word. Well, I guess it's right here too, right? Distance. This is why the circle is related to the distance formula. So if you take the distance formula and apply it to this scenario here, we'll let h and k be x1 and y1, and we will let our variables x and y get plugged in for x2 and y2, and then the distance is the radius, right? So take the distance formula, which was d squared equals x2 minus x1 squared plus y2 minus y1 squared, and plug those details into that formula, right? So we're going to plug in, for x2, y2, we're going to plug in our variables, x and y, right? So this will become x, and this is going to become y. For x1 and y1, we're going to plug in h and k, which are the specific coordinates of the center, which again, those numbers don't vary, right? That center is fixed, and it's, going to be a certain number, it doesn't change. So we're using h and k to represent those. So h is the x coordinate of the center, k is the y coordinate of the center. And then for the distance, we are calling that r, that's the radius. I should have drew my arrow from a different angle. Guess I'll bring it up top here. All right, so the distance is going to be the radius. And so what we end up with is this formula here, which really is just the distance formula. But it's been modified for the situation of looking at a circle, right? So I'm saying that kind of funny, but we've modified the distance formula. We've adjusted it so that it represents the details that you encounter with a circle. All right, and so that's the formula that you're going to see here. This is called the standard form for a circle's equation. That's kind of a weird way to phrase it. The standard form of the equation of a circle. Right, that's what I was going to say. Now here, it's the same formula we were just looking at that we have on the screen up there. They just flip it around the other way and put r squared on the right-hand side instead of having r squared on the left-hand side, which is actually more useful. So, all right. So it's really, again, the same formula that we had right here. They're just taking the r squared from the left-hand side, moving it to the right-hand side instead. So that's the formula for a circle. So if you're given an equation that looks like that formula, then the graph for that equation is going to be a circle. So maybe what we could do is, I'm going to skip these examples for the moment. We'll come back to them. Let's look at these where the equation's already set up, so we can practice extracting that useful information out of it. In fact, let's do part B first, because honestly, that, even though it looks more complicated, that's actually going to be a little easier to do. So the formula for a circle is x minus h squared plus y minus k squared equals r squared. So if you line up the formula to your equation, you can get all the relevant information about the circle out of that equation. What's the relevant information? The center and the radius. That's what we would need to know to be able to graph that equation. So the center is at h comma k, and the radius is the value r. Right. So h, if we look at how our formula lines up with the equation, h lines up with the number 3. Notice that our formula has a minus sign between the x and the h, right? And the equation here also has a minus sign. H is what comes after the minus sign. So what we want to grab here from this is just the number after the minus sign, which is the number 3, right? So h is equal to 3 in this case, right? Now k, again, is the number you get after the minus sign in the parentheses with the y variable. Our equation doesn't actually even have a minus sign there. So what you would have to do if you really want to be pedantic about it is you have to rewrite this equation with a minus sign. You might say, well, how do you do that? You just rewrite plus 4 as minus negative 4. And then k is the number, I don't know, how do I want to draw this here? K is the number, and I should have another parentheses there. K is the number that comes after, so let me just kind of start over here. There should be another parentheses there. K is the number that comes after the minus sign, which is going to be negative 4, right? So if you rewrite that plus 4, so it has a minus sign, so it matches up better with the formula. K is the number that follows that minus sign, which is going to be a negative 4 in this case. And so K is negative 4. And so our center for this circle is at 3 comma negative 4. So that, you could write it out like that if you want to like literally match up the formula to the equation. Rewrite any plus signs as minus and negative. But the shortcut there is you just take the opposite sign of whatever you're seeing in the equation, right? So if you want the shortcut, this is the shortcut, right? If you have, let me use a different color here. If you have I already have orange, I don't know what one to use here, that's a little bit different. I guess brown. So if you have a minus 3 in the equation, then the center will be at positive 3. If you have a plus 4 in the equation, the center will be at minus 4. So basically just take the opposite sign of the number that's actually in the equation. If it's a minus, then your coordinate should be positive. If it's a plus, your coordinate should be negative. Just take the opposite sign. All right, now that's the center. The radius is the number that is on the other side of the equation, but that number on the other side of the equation is the square of the radius. So notice our formula here, how it lines up, is that 12 matches up to r squared. We want to know what just r is equal to. So what you have to do with that number is line it up with r squared, right? R squared lines up with 12, so those are equivalent to each other, right? R squared is 12. And then you have to solve that for r by taking the square root of both sides to get r by itself. So basically, again, the shortcut is the radius will be the square root of whatever that number is. Right? So whatever number is by itself on the right-hand side, the square root of that number will be your radius. But this is how you would set it up to get that information. Right? Now, if you type in square root of 12 as your answer, it's going to count that as incorrect because that's not simplified. So it wants it in radical form, I'm pretty sure, but you have to simplify the radical. So 12, we want to split that up as 4 times 3, not 6 times 2, because you can't take the square root of 6, you can't take the square root of 2. You want 4 because you can take the square root of 4. Square root of 4 is equal to 2, and then we just copy down the square root of 3, and that would be our radius for this circle. Right. So that's how you find the center and the radius. I skipped part A because what's a little bit challenging about this one is that we have some missing numbers. And so it's just harder to line things up here. But the answer actually works out a lot nicer for part A. It's just a little bit harder to see. So because there are no numbers here with x, that means in this case h is equal to 0, right? So if there's no numbers in the parentheses with the x squared, then h is equal to 0, which means for your center, the x coordinate is going to be 0. And the same thing happens with y in this case, right? There's no number with the y variable either, and so that means this must also be equal to 0. And so k is equal to 0, which means the y coordinate of my center is equal to 0. So if the numbers are missing, use 0 as your coordinate for that. And then in this case, the radius is going to be not 49, but the square root of 49, which is going to be 7, right? So that one simplifies pretty nicely. And so this circle would be centered at 0, 0 with a radius of 7. Right. Now I do want to go back and do those previous examples I skipped, but we might as well do this example while we're here. So this time we're being asked to do the same thing we were just doing, find the center and the radius, but then also use that information to graph the circle. So we'll do that as well. Pause the video if, I think this would be a good chance for you to practice this. So pause the video and you determine what you think the center and the radius should look like. And then resume the video to see the answer that you should have gotten and make sure you're getting the right answer. So the center in this case, you should have gotten positive 3, positive 2. So again, we want to take the opposite sign of the numbers that we're seeing in the equation. H is positive 3, k is positive 2. And then the radius you should have gotten this time is 6, right? That's the square root of 36. That's how we're getting the radius here. All right, so that's our center and our radius. First, to graph this circle, you will want to find the center, right? So 3, 2 is going to be right here. I like to mark that point with an X. Now on my math lab, if they make you graph this manually, you'll just plot that point like any other point. But I really like to emphasize, it's a funny thing because the center is actually not part of the circle, right? The circle is all the points that are 6 units away from that point. But that point itself is actually not part of our graph, right? So I don't like to do a dot there because I don't want you to think the graph should somehow go through that point. The graph is not going to go through that point. We want all the points that are 6 away from that point. Now, that means we want the points that are diagonally 6 away, which would be hard to measure, right? I don't have a ruler. It'd be hard to gauge exactly how far 6 would be away from the center. A ruler probably wouldn't work here anyways, because again, we'd have to size everything exactly right for the ruler to work correctly. So the points, we want to find the easiest points that we can find that are 6 away from the center. And the easiest ones to identify are vertical and horizontal, right? We can find a point that's 6 units up and 6 units down. All we have to do is count. Go up 6, go down 6. Diagonally, you can't just count off the marks on the graph, right? So we're starting at, so let's go vertical first. We're starting at y equals 2. I'm going to go 6 up from here. So, 1, 2, 3, 4, 5, 6, and I get that point right there. So I'm going directly above the center. Don't mark it over here on the y-axis. That's a mistake students will make. They'll plot this point right here, but that is not on the circle. It needs to be 6 directly above the center. So make sure you're staying above the center, going up 6, and then you get a point there. Now I should be careful not to mark these as dots because those are not points that I'm graphing there. So I just wanted to show how I was counting. Then we could go 6 down to get another point. Now, if you're on MyMathLab, you're done at this point. You plot the center, and then you plot 1 point, and MyMathLab automatically draws the circle from there. So you just need 1 point. But if I'm drawing this by hand on paper, I would like more guidance on how to draw this circle. So I don't want just the 1 point. I want to get kind of some guideposts all the way around. So I'm going to go 6 down as well, right? So let's use the same color here. So we'll go 6 down. Let's do this. 1, 2, 3, 4, 5, 6, right? So I end up here, and that'll be another point, and that's 6 below, right? The center. Make sure, again, you stay lined up with the center. I think it's pretty clear. I'll leave those dots there. Then we could also find 6 units horizontally, right? So 6 units to the left would be 1, 2, 3, 4, 5, 6. Be this point right here. And then 6 units to the right. 1, 2, 3, 4, 5, 6. Right, let me get that point there. And that gives me 4 guideposts to help me draw the circle. So what I do from here, and I might botch this, but you try your best to draw a circle connecting those 4 points. So just draw a round shape going through those 4 points, make it as round as you possibly can. So it's gonna look something like this. Okay, actually I didn't do too bad here. So, all right, and that would be our graph for this circle. All right, let's jump back to these examples here. We have, this time we're going in the opposite direction. We're being given some information about the circle, and we want to find the equation. So in the previous examples, they gave us the equation. We're extracting information out of it and graphing. In this case, they're giving us the information. We need to find the equation, right? So you want to use, really, I guess it says use the equation here. Maybe that is what the directions say on MyMathLab, but really you want to use that formula, right? X minus h squared plus y minus k squared equals r squared, right? The center is at -2, 0. That's my h and my k. The radius is 9. That's my value for r. So this is about as easy of a problem as we can get with this material. They give us all the numbers we need. We just got to plug them into the formula. So we're going to have x minus h, which is -2 squared, plus y minus k, which is 0 squared, equals r squared. And in place of r, we're putting 9. So we get 9 squared. The minus, I'm jumping ahead here, minus a negative becomes plus, is what I was trying to say. So I get x plus 2 squared. Here, the 0 just drops out, so all I have is just y squared, so I don't need the parentheses anymore. I'll just have y squared. And then 9 squared is going to be 81. And so that would be the equation of a circle with a center at -2, 0 and a radius of 9. Part B is going to work the same way, so maybe you could pause the video and then resume it to see what the answer should be. So pause the video, give this problem a try yourself, and then resume it to see the answer. What you should be coming up with here, I'm not going to write the formula out, I'm just going to write the answer down, is this. So x minus 3 squared, y minus 4 squared, and then what's going to happen with this is you'll get r squared. I guess I said I wasn't going to write the work down, but I was just worried. You might not understand why that's just going to be 3, because you're taking the square root of 3, and then when you square it, the square root cancels out the power of 2, you just get 3. So that's how we get 3 there. Okay, so let's take a look at, let's see if there's anything else on this page, actually. No, we're good. Okay, so I think this is the last topic. Let's see, I have the notes printed out here on paper. Yeah, so this looks like the last topic and the notes. These are pretty tough problems, so just to give you fair warning here. They're calling it the general form for the equation. So notice the previous formula was the standard form for the equation of a line. This is called the general form, which again, I've never really had seen this terminology before. And it's no matter. The issue here is that we can't get any information off of this equation. By looking at this, you can't tell me the center, you can't tell me the radius, because the equation's broken. It's kind of basically the way I think, I don't know, this is kind of a weird way to think of it, but it's just like the standard form, the one we were using previously, is nice and well-formed and buttoned up. This one is just spilled out, right? It's like everything escaped from the zoo. Maybe that's a good way to put it. So everything's just all over the place. So what we have to do when we're given an equation that looks like this is we have to rewrite it into standard form to make it useful. Otherwise, you're just not going to get anywhere with that equation. So our goal is to rewrite these general form equations back into standard form so that we can actually extract useful information out of it to graph or whatever we want to do. The process for getting it back into that form is called completing the square, which we briefly covered in chapter 1 when we talked about there was a method for solving quadratic equations involving this approach. And so that's the method that we want to use here. It's going to be even easier here because the x squared and the y squared, for it to be a circle, those have to be 1x squared and 1y squared. So we don't have to worry about numbers in front of the square term, which makes completing the square more difficult. So with basically a being equal to 1 here, completing the square is, it's the easiest, situation we could have for completing the square. Yes, it's a tough problem. The first thing I would do is group the x's together and the y's together. So I'm going to just rearrange things here. Because they're already on the same side of the equation, we can just, you don't have to subtract the 4x. You just move it over, right? So we're going to get x squared, and then I'll put the plus 4x next to that. And then I'm going to leave a little space, and you'll see why here in just a minute. I'm going to leave a little space here, and then I'll put the y squared minus the 4y. And then, so that takes care of these two terms here. The y's get lumped together over here. And then the 17 we actually don't want to leave on the left-hand side. This time, to move it to the right-hand side, I will have to change the sign of it, right? I'm going to have to add it over there. So again, leave a space after the 4y, because we'll need some space there for what we're about to do. And then the 17 is going to find itself on the right-hand side of the equation, right? So that would be the way I would start setting up my equation. And then you want to complete the square for both x and y. So completing the square of the process should go pretty smoothly because a is equal to 1, but the drawback here is we have to do it twice for x and for y. And the way completing the square works, so we'll start with the y variables here, is you want to take, after you've confirmed a is equal to 1, you want to take b, which is 4 in this case, so b is equal to 4. You want to divide that by 2, which will give me 2, and then you want to raise that to the second power. And I know that's, several steps there, none of which are difficult, right? Unless you get a fraction, that can make it more challenging, but this time we don't get a fraction, so everything works out nice, right? B divided by 2, and then raise it to the second power. The number you get at the end of that process is the special magic number that you need for this to factor as a perfect square. So what we need to do for the x's is we need to add a 4 to them to make this factor in a special way like this, to make it factor like this. Right? So that's our goal here, is to figure out what number is needed here so that I can take this expression and make it look like this. And for it to look like that, what we have to do is we have to get the same factor twice. We have to get x minus h times another x minus h, which allows me to write it as x minus h squared. Right? If I add 4 to the left-hand side of the equation, I have to add 4 to the right-hand side of the equation. So make sure you don't forget to balance that out. Now this factors in a way I think that you should be able to tell pretty quickly. Two numbers that multiply to 4 but add to 4 are 2 and 2, right? Positive 2 and positive 2. And that's what should always happen if you do this process right, is the two numbers you're looking for will be the same. It'll either be 5 and 5, -4 and -4. You should get the same number twice in both of these factors, which allows me to write it as a square, which is the whole point of doing this. Because once you write it as a square, now it matches back up to the nice formula. And now I can see what h is equal to, right? H is equal to -2. And that helps me find the center, right? So we do that for x. We got to do the same thing for y. So maybe pause the video here and see if you can complete the process for y. What you should get is b, which is -4. We're going to divide that by 2, which gives me -2. And then we're going to raise that to the second power. Now, -2 to the second power is +4 as well. So we're going to add another 4 here to make this factor in that special way. If I add 4 to the left-hand side, again, I have to add 4 to the right-hand side. This is going to factor as y minus 2 times y minus 2, because this time we're looking for two numbers that multiply to 4 but add to -4. So that's going to be -2 and -2. And that I can write as x minus 2 squared. And then this plus sign is going to copy down here. And on the right-hand side, we'll go ahead and add these numbers together. Predictably, you get something nice. You get 25. Right? So now we've rewritten that equation into standard form, which then allows me to find the center and the radius, which is not asking me to do here, but I'm just going to do it anyways. So we would get the center would be at -2, 2, and the radius would be at 5. And then we could go on to graph this equation if we wanted to do that. Right. So remember, to get the center and the radius, you want the opposite sign here. So we have +2, that's going to make the center at -2. This is a -2, that would make that at +2. So that'd be my center and my radius. Okay, so that's how you complete the square. I think I have one more example for us to look at here where we're also asked to graph. So this one's going to kind of have us do everything, and we're also going to, I think, be dealing with some fractions here. So let's take a look here. So we'll start off the same way. So let me zoom in a little bit more. Rearrange this into a more useful form, right? So we'll put the x's together, x squared minus x. Leave a space for the number that I'm going to add to make that factor the way I want it to factor. Then we'll put the y's together, y squared plus 6y. Leave a space. And then the 9, I'm going to subtract that to the other side, which will be kind of silly, you'll see in a moment, but that's really the standard way you want to set this up. Now, I know we did x first last time, but it's going to be easier to do y, so let's just do y first because it's easier, right? So for y, b is equal to 6, right? That's our value for b. We divide that by 2, so 6 divided by 2 gives me 3, and then we raise that to the second power, so 3 squared is going to give me 9. So what's kind of silly is that actually we already had that there, right? The 9 was already there, but it's fine to go ahead and set it up like this. We didn't know that 9 is the number that we were going to want. So we'll add 9 there, so this will factor in the special way we need it to factor. If you add 9 to the left-hand side, you have to add 9 to the right-hand side. Y is going to factor as x plus 3. Sorry, I said x. The y terms are going to factor as y plus 3 and y plus 3, which I can write as y plus 3 squared. So that takes care of y. For x, it's not quite as smooth sailing. B is equal to -1 in this case, right? B is, it's invisible, but it's a 1, right? -1. We're going to divide that by 2, so we get -1 divided by 2, which doesn't divide nicely, which means we actually just have to leave it as a fraction. -1/2, right, is what it's going to be. And even though we kind of don't like how that number looks, we still have one more thing we have to do to it, which is we have to raise it to the second power, unfortunately. But squaring a fraction is not as bad as it sounds. You square the top, you square the bottom, right? So the negative gets canceled out. 1 squared is going to be 1, 2 squared is going to be 4. That's the magic number that I need to have here for this to factor as a perfect square. If I add 1/4 to the left-hand side, I have to add 1/4 to the right-hand side. So let me kind of organize this a little bit better because it's getting a little messy here. All right, now, that was kind of bad, right? Fraction. It gets a little worse here because now I want to factor this, but I can't factor it very easily because it's a fraction. I have to find two numbers that multiply to 1/4, but add to -1. That's hard to do because it's hard to figure out fractions that behave that way. So I have another shortcut for you that we could have used back here, right? And maybe you noticed this pattern when we went through this problem earlier. But the number we're getting inside the factor here actually matches the number you're getting here when you've divided b by 2. So if you go back a step, when you divided b by 2, the answer you get there is the number that's going to show up in the factor when you factor it as a perfect square. And you might say, well, then why didn't we just stop there? Well, because we still needed to square it to find out the number we needed to add to both sides of the equation, right? So you need both of these numbers. You need the final number here to know what you're adding to both sides to make it factor the right way. But then you could go back to the previous step and get that number, and that number is the number that will show up in the factor after you factor it. The same thing happens over here, right? We got -2 after we divided by 2, and it was -2 that shows up in the factor, right? So, and it happens here, right? We got 3. 3 is the number that shows up in the factor. So it will happen here as well. It's -1/2. Those are the two numbers that are going to show up in my two factors. I say the two numbers. That is the one number that shows up in my two factors, right? It'll be x minus 1/2 times x minus 1/2, which I can write as x minus 1/2 squared. All right. Now, when I combine these numbers together on the right-hand side, the 9's cancel out, and I just get 1/4 on the right-hand side. So this is how we write our equation in standard form. And now that it's in standard form, we can find the center and the radius. The center will be at 1/2 comma -3. The radius is going to be at 1/2. And you might say, how are you getting that? Well, the number we have on the right-hand side is 1/4, but remember, that's the radius squared. The radius squared is 1/4. To get the radius, I have to take the square root of both sides, and I'll square root the top, square root the bottom. That gives me 1/2. So the radius is 1/2. And so let's go ahead and put this graph together, right? So we'll graph this here. So we have, so notice they've already marked the numbers here. So most of the examples we've done so far, they don't actually put any numbers down, but this time they're doing that. And so this is 1 right here, which means this is 1/2, right? So 1/2 comma -3. This is -3 right here. Let's try that again, -3. It's going to be right here. So again, I'll mark it with an X, right? Because that point actually isn't on the circle. It's the center of the circle. And then I want to find all the points that are exactly 1/2 away. So I'm going to go 1/2 to the left, which is going to be this point here. 1/2 to the right, which is going to be at 1. 1/2 up, right? Because again, this is -2, so this is -2.5 right here, right? And then 1/2 down, and we get this pretty tiny little circle around the center. So it's going to look like this. So that is our graph, and that is the end of section 2.8. Thank you for watching to the end.